It's a big world out there, with plenty to do and explore.
And there are a lot of big problems facing us right now, like pollution and global warming.
Now is the time that we all should get together to help solve these problems. So, where do we start? Well, the first step is learning all that we can about the problems facing the Earth.
And then figuring out ways to solve them. We call that exploring.
Right now, we're going to explore
Recycling.
Recycling is defined as the act of taking used or abandoned materials and turning them into new products. Recycling is good for the environment because it gives useful materials a second life. It reduces consumption of raw materials, and it can conserve energy, air, and water.
Despite what some people believe, recycling is not a new idea. In one form or another, humans have been recycling for centuries.
Well, before the fall of Rome, bronze items were being retooled for different uses. In pre-industrial Britain, the ashes produced by fire were used to make bricks. As early as 1690 in America, there was a paper recycling mill in Philadelphia. And Henry Ford, a man who believed in efficiency and thriftiness, set up a disassembly line at his automobile factory in Detroit so that parts of old Model Ts could be reused in new vehicles.
He even reused the wooden shipping crates that parts came in as floorboards in his new cars. But modern-day recycling dates back to 1970 and the very first Earth Day.
It started when cities and towns handed out plastic bins and ordered paper, cans, and other trash to be separated before pickup. In the beginning, America's only certified recycling program took 15 million tons of trash out of landfills.
Today, there are more than 8,600 recycling programs, diverting over 82 million tons of trash away from landfills.
But trash is still a huge problem. Every year we dump about 68% of all our garbage into landfills. And that amounts to well over 100 million tons, and rising every year. If we recycled more, we can reduce that number.
So, what actually happens to the trash we put in the recycle bin? Let's follow an aluminum can, a piece of paper, and a plastic bottle as they are recycled, and see how it all works.
When the trash truck empties your recycle bin, the first stop it makes is here, to a materials reclamation facility, known as a MRF station. Since plastic and paper and metals are all recycled in different places, they have to be separated from one another, bundled together, and sent to the proper plant. It's a job that requires a keen eye and split-second decision-making by these workers. Different kinds of paper have to be segregated according to type. Aluminum has to be separated from other metals. There are 7 different types of plastic. They have to be sorted according to their category. Once sorted, the material is either baled, shredded, or squeezed together so that it can be easily shipped. Before long, these bales of cardboard will be on their way to a paper mill in Kalamazoo, Michigan. These old plastic bottles will be loaded on a truck and sent to a recycler in Troy, Alabama. And these cubes of aluminum cans will be put in a shipping container and sent to a plant in East Tennessee. Aluminum is one of the most efficient and widely recycled materials. Over 51% of all aluminum cans are recycled, more than any other beverage container.
When recycled, they save 95% of the energy used to make new cans, not to mention the energy and pollution caused by mining, refining, and manufacturing new ones.
This plant in Alcoa, Tennessee, recycles enough used beverage cans to produce billions of new ones each year.
When old cans arrive from the MRF station, the cubes are first cut into smaller pieces, called blocks, to make it easier for machines to handle them. The blocks are then mechanically cleaned to remove paint, dirt, and other impurities before being loaded into a furnace to be melted down.
The remelt furnace heats the aluminum blocks to about 750 degrees centigrade, turning them into rough molten aluminum. Engineers then use spectroscopic analysis to determine what elements they should add to get the exact aluminum alloy that they are looking for. When the mixture is just right, the furnace is tapped, which means the molten aluminum can be poured into ingots, billets, or rods. Or it can be atomized into powder.
Since this aluminum is destined to be soda cans again, it will be poured into ingots. Ingots are formed when the molten aluminum is poured into molds, using a lot of electricity. Ingots can be up to 25 feet long and weigh 44,000 pounds each, and are very, very hot when they come out of the molds.
They are then sent to the hot rolling process, where they pass through 3 different rolling mills. In the mills, the 21-inch thick ingot is squeezed into a sheet of aluminum 3,000 feet long and 1/8 of an inch thick, which is then rolled up into a coil, all in about 7 minutes.
And if you've ever seen your mom making biscuits, there's a rolling out, as she's rolling that dough out, that's the same principle as how that aluminum ingot is rolled into a coil. It has tremendous roll forces on the rolls. Those big, huge rolls press on it harder and harder as it rolls. And as it goes through those rolls, it takes that big, huge chunk of aluminum and then rolls it longer and longer and thinner to approximately 1/8 of an inch. And as it's rolled through there, it's rolled back and forth through the process where that coil would be over 1 mile long when it's through with its 1/8 of an inch finish at the hot mill. So that coil will weigh about 32,000 pounds. That coil will make about 1.5 million cans eventually.
The coil moves on to the cold mill, where it is unrolled and squeezed again. This time to a few thousandths of an inch thick, at about 60 miles per hour.
So when one coil runs, the next one is hooked to it. That power that we go through, the accumulator tower, gives us several minutes to run one coil, start another one without the process ever stopping. Then we take that coil through the process, inspect it through all the way, make sure we have the exact coil that we want for our customer, wrap it in plastic, put it on a rail car, put it on a truck, and ship it across the country to the can maker.
Called can sheet, the recycled aluminum is now ready to be stamped into cans.
At the can plant, the 6-foot wide, 30,000 foot long coils are loaded onto an uncoiler and lubricated before being sent to the can shaping process. A cupping press cuts the aluminum into shallow cups at the rate of about 3,500 per minute. From there, the cups are drawn up through a series of iron rings that shape the aluminum into what is starting to look like a can. The tops are then trimmed so that each can is the same height and width. A washer cleans and dries the can bodies so they can be decorated.
Next, the cans proceed to a printer where the can spins around a large wheel and the label is applied with up to 8 different colors of ink at the same time. Then, the cans go into an oven that bakes on the paint to prevent chipping.
From there, the inside of the cans are coated with a spray so that none of the contents ever touch the metal itself.
The top of the cans are then made narrow, called a flange. This will help seal the lid in place after the can is filled.
Finally, all finished cans are tested for leaks. A special light tester can find holes in the aluminum that are smaller than a human hair. The completed cans are stacked, put on pallets, and shipped to yet another plant, where soft drink companies fill the cans, attach the lids, and secure the easy open tabs on top.
Did you know it takes about 60 days for a can to be recycled and returned to a store shelf as a new can?
Here's another fact. Did you know that about 40% of everything we throw into a landfill is paper. And although almost all paper can be recycled, some types are harder to recycle than others.
For example, used paper plates and pizza boxes are not usually recycled because the food cannot be easily removed during the process.
So how is paper recycled?
The process is called repulping. Because all paper has to be reduced to its basic element, wood pulp, before it can be made back into paper. The process is so simple you can easily demonstrate how it's done at home. All you need is a paper shredder, a blender, a sieve, a screen, and a rolling pin. Then find some old paper. An outdated phone book or store catalog will do.
First, shred the paper. Mix the shredded paper in a food blender filled about a quarter of the way with water.
Be careful not to burn out the blender because paper can be hard to mix with liquid. However, when the paper has turned to a mush, you've repulped it and completed the first step in the recycling process.
Now use the sieve and your hand to press out as much of the water from the paper pulp as possible. Then, use the rolling pin to flatten out the pulp on a screen or some other flat surface, just like you'd roll out a pie crust to make a pie. Finally, dry the pulp as best you can. A hairdryer works, or you could just set it out in the sun to dry.
This may take some time, but as the pulp dries, it hardens back into paper. Before long, you've recycled an old phone book into your own unique paper wall hanging.
This paper mill in Kalamazoo, Michigan does basically the same thing, recycling thousands of bales of used cardboard into 100,000 tons of paperboard every year, enough to make 1.5 billion cereal boxes.
Well, we need to dilute all the fibers back down again so we can reform them. It's just like if you're making paper at home, you tear the paper up into little pieces and you put it in water again, and the water breaks the paper down. We bring in bales of recycled fiber from a lot of different areas. It could be like from a grocery store, and we will pulp it. Pulping to us is you just take that fiber, a big bale, and put them in a big blender. It's a bit like an osterizer like you have at home with lots of hot water and mechanical energy, and we just pulp them up. We just tear it apart, and it makes it look kind of like oatmeal. It's a slurry. We turn it into pulping, same as making it into a slurry.
After that, the pulp is put through a filtering process to remove impurities, such as coatings, additives, and ink that may still be mixed in. This clean and de-inked pulp is now called stuff and is ready to be made into paper.
The mixture enters what's called the head box at the beginning of the paper machine, one of the hottest and most humid places on Earth. It can reach 130 degrees Fahrenheit inside a paper mill with 100% humidity. The watery mixture is sprayed continuously onto a huge flat wire screen, similar to what you did when you rolled out your wet pulp at home. The screen moves quickly through the paper machine, which drains out the water from the mixture.
We are putting about 50,000 gallons a minute of fiber and water out onto a traveling wire, and we actually drain the water out that fast to drain all the water from the pulp slurry.
Before long, the recycled fibers in the stuff bond together, and the liquid begins to form into a solid sheet.
The water itself creates a hydrogen bond, it's called, and as you dry the paper, these hydrogen bonds form and hold all the fibers together. After we actually make the paper, we have to add a coating to it, and the coating's very similar to a latex house paint. So we apply the coating or the paint onto the paperboard, so that provides a nice clean white surface for printing. And we then wind it up into a big roll. The roll will weigh about 2 tons, which is the size of a small car. And from there, it's actually printed and turned into food packaging, primarily a cereal box. So if you had cereal this morning, it's very likely that that paper was made right here in Kalamazoo, Michigan.
Once you take the cereal home, eat it and put the used box back in the recycling bin. the whole process begins all over.
Did you know recycling just a ton of paper saves about 17 living trees? Think about that the next time you go to throw away an old piece of paper.
Now, what about recycling plastic? Compared to metal or paper, plastic poses unique challenges because there's so many different types of plastic, 7 in all.
If different types are mixed together, they won't blend. They tend to separate like oil and water.
Another problem, most plastics contain a lot of dyes, fillers, and additives, which are hard to remove.
So, unlike other materials, you can't just mix old plastic and expect it to recycle. Recycling plastic requires 4 processes: grinding, washing, drying, and pelletizing before it can be made into something new.
When old plastic first arrives at the recycler, the large bundles are set to the head of the wet line, where the shipping straps are removed and the old bottles are sent up a conveyor and into a large rotating drum that removes bottle caps, labels, and anything else that may be packed in with the plastic.
This is what we call a trommel, and it's a large drum. And what that does is it helps to break up the bottles. Since they've been crushed into these very tight bales, it helps to separate out the bottles. As the bottles are rotating through that drum, dirt, debris, non-plastic items such as metal that may have been picked up along the way in transport, it all gets knocked out of that trommel system. Because what we're trying to do is remove all contamination so that when those bottles make their way into our wash line, that we are washing bottles. The wash line process is almost like a washing machine, a series of rotation systems and a series of wash and soap rinses. It's an agitation system where the material is constantly rotated. There is a series of caustic soda and water rinses to clean that material, to strip the material away of any contamination, whether that's paper, glue, foil, dirt, any kind of sort of contamination. As it makes its way through the wash line, that's when the rotation blades come in and they actually begin to chop the material into a flake form. And it goes through a series of these so that each piece is constantly being rotated and cleaned and given a thorough washing and rinsing. As the material makes its way down the line, it's getting cleaner and cleaner. Well, at the final stage, after the final rinse, the material is dried, and at this point they're in small flake pieces, which is approximately about 1 inch to 2 inch size pieces. That particular quality control officer that you see is checking the material at the end of the line. And what he's doing is he's going to check for quality. He's going to put that material into a lab where they'll check things like melt flow, density, and just ensure that at every step that we're producing the highest quality product that we can. And when you see the big drums falling down with those plastic pieces falling down, that's the final flake, meaning that the material has thoroughly been washed and size reduced and is ready to be extruded. The extrusion portion is sort of like the cooking or the kitchen portion. We've just left the laundry room where the material has been washed, and now we're in the kitchen where we're actually compounding the material. We're heating it up so that it can melt and it can flow through a series of filters and blades, and then it's chopped into these final small pellet form. The extrusion process is almost like the old Play-Doh, the Play-Doh machine.
Pellets made from colored plastic generally turn out dark, and plastic recycled from clear plastic generally produce white pellets.
The recycler packages these pellets in big boxes or puts them in a rail car and ships them to manufacturers who turn them into any number of products, from carpet to lawn furniture, toys, to more plastic bottles.
Recycling plastic prevents us from having to use up precious crude oil in order to make new plastic products. But for all these efforts, we recycle far less plastic than we do paper or aluminum.
And not everyone agrees that recycling is really the best way to deal with environmental problems. Critics claim that recycling is a zero-sum game, which means it consumes as much energy and creates as much pollution as it saves. Just look at the number of miles each of our recyclable items have had to travel just to be recycled. Moving all those items, all that distance, uses up a lot of natural resources and creates a lot of pollution.
And what about those people who claim there is really no garbage crisis at all? That there is plenty of landfill space and that recycling just makes us feel like we are doing something good for the environment, when we should actually be using less stuff.
There's some large misconceptions and myths that, the investment dollars don't make sense, but again, people don't understand that there's a value.
I feel recycling is very important to our country, to take all that material out of the landfill and try to reuse it as much as we can.
The most efficient and the most environmentally friendly thing you can do is make the same product over and over again. As a can, like we said, a can can be melted forever. For as long as we will live, that same can can be in the process.
I feel like at the end of the day, if I'm saving material from going into landfills, I'm creating a better tomorrow. For me, for my family, but for our nation as well. And so it costs a lot of money, but it also costs our Earth's natural resources.
Whatever you believe, recycling is here to stay, and people are discovering new and more efficient ways to recycle all the time.
There's still a lot more to learn about the world and what makes it go around.
And it's never too late to explore. You might be surprised about all you can learn. Until next time, I'm Andrea.
And I'm Michael. See ya.
Out there exploring.